This is the OsKyr project, an electronic Morse key. The design is just about finished, and the next step is to convert this Heath Robinson layout onto a printed circuit board and build it into a box. Now, I've built a few keys. They were called L-bugs, or electronic bug keys, back in the 1960s and 70s using discrete transistors. But the hobby fell by the wayside, as did all the gear, so this is my take on a replacement after a 40-year lapse. I realise most of this is just reinventing the wheel, as there are loads of keys out there, but it's my way of getting the exact wheel I want, and it's a fun project. If you're interested, I'll be publishing the schematic and firmware code later. It's compiled for an Atmega 328 microcontroller, as used on many Arduino boards. I've been using the Nano and Pro Mini boards for these lash-ups, but anything based on that chip should work. And if the PCBs work out okay, there may even be some spare blank boards, as I'll have to order a minimum quantity. Now, I did look at a few modern keys, but they had too many features for me, such as contest modes, internet logging, memories, iambic modes, and so on. So if that's your interest, this one isn't for you. OsKyr is more about ease of use and helping to generate code which you would be happy to listen to, especially if you're new to keys or very rusty like me. Now, one problem when you're just starting with CW using any sort of key is that it's very easy to rush things and run letters together without leaving sufficient gaps. Another problem specific to automatic keys like this one is overrunning or keeping the paddles pressed too long, which generates spurious dots or dashes at the end of letters. If I send a D, da-di-dip, and hold the paddle just a fraction too long, I get an extra dot, and that's a completely different letter. Now, these all make the code very hard to copy. And many electronic keys have features to address these, such as autospace, and OsKyr does the same. But I've not come across any which actually encourage the operator to improve their keying. So there are a couple of potentially novel features. I'll split the video into two parts. This one describes the main controls and design principles, and the second part covers the additional features. So running around the board, as with many keys, there's a display screen for various options. But as OsKyr stands for old school key, it uses real knobs and switches to keep the menu diving to a minimum. All knobs are old school potentiometers, or pots, and the values can be shown on the screen for clarity, like this speed control, but they work regardless of the display. And because they're not continuously rotating encoders, you can use knobs with pointers and print legends on the front panel. Anyone remember Letraset? So you can see at a glance what the settings are and turn features on and off for instant feedback. Now, it may seem trivial, but there's also a knob for the screen contrast. If the setting is buried in a menu, it's catch-22 if you can't see the screen because the contrast is wrong. This is the menu scroll knob, which scrolls through various items. And most of these are for information only, as the values are adjusted directly by the pots and the switches. Here's the side tone pitch. You have to excuse the awful sound. This part's not quite finished, as it just feeds a square wave into a piezo speaker. This was fine for development, but it's now time to add a filter and a decent speaker. The side tone can be switched on and off, so you can use the one on your rig, but I wanted a built-in one for practicing off-air. This is the weight control, which alters the dot-to-gap ratio. This can be frowned upon by some, but others say it helps readability in some situations, so it's there if you need it. And there's also a switch for this, so you can leave the knob set to your preferred value and switch it on and off as needed. 3 push buttons. 2 are the usual increment and decrement for changing values on the screen, although as mentioned there are only a couple of these. There's the tolerance values, which I'll explain in part 2, and the range limits for the speed control, the min and the max. Now I remember the speeds on old Kyrs going up to 40 words a minute or even more, and this was and is way above my limit. And even though electronic Kyrs make it easier to send at these speeds, there's no point if you can't read it. So the min and max values can be set to something more realistic for your skill level, then there's no temptation to set the Kyr too fast. As you can see, these values are more than adequate for me at the moment. And the final options are for saving the settings, so they're retained after you switch off. And there's also a restore to factory settings option, although there's not much to save and restore, as most settings are defined by the pot and switch positions. The third button toggles the display from this LBUG setting mode into decode bug output mode, so you can see what you're sending. Now, I've been using a straight key on the air so far, so I'm finding this very useful for getting back the knack of using an automatic keyer again. The 6 toggle switches shown here are just the ones connected to the MCU controller. There are others not shown for the power, transmit on off and side tone on off. This was the switch for the weight control. I'll turn that down to say there. Has no effect until you switch it on. And this one toggles between normal automatic mode and manual mode. So in manual mode, it converts both paddles to straight keys. So you can tune up your aerial and transmitter, or maybe use the paddle as a side swiper, which obviously is not my forte. Right, that's the end of part 1. I'll cover the more advanced switches and features in part 2, so see you then.